Bismillahirrahmanirrahim, guys. Assalamu alaikum. Mr. Atiq is here once again. We have week 14 chemistry lecture, chapter 22, sections revision or review. Okay, remember you need to study from 699 to 703 pages for this review. Understand? And all are just gonna to repeat all the things that what we studied, in section 1, 2, 3, 4, like this consecutively or respectively. Remember, in organic chemistry we studied like the hydrocarbons, understand, functional groups, alkanes, alkenes, and all those things, alkynes and their nomenclatures as well, their medicinal uses as well. Understand? So all are those things that like we need to cover in the revision sections as well. Okay, so the previous slides I took it somehow, and somehow I prepared some as well, because this is just long chapter, you can say, okay, or long revision, you can say. So I will just study it like this. Okay, just study it, just overview it, and then clarify your concepts over the previous lectures or videos. The preview hydrocarbons, alkanes are there, cycloalkanes, system names and alkanes, of alkanes, properties and uses of alkanes, unsaturated, that is what we studied before as well. Hydrocarbons, the definitions, all what are hydrocarbons, look at saturated hydrocarbons are there as well. Compounds that contains only carbons and hydrogens that make up the simplest class of organic compounds and all those things. Then the saturated hydrocarbons are the second type of hydrocarbons as well. These are the hydrocarbons in which each carbon atoms in a molecule form 4 single covalent bonds with another atoms. Then alkanes comes, as I told you, the A in E is A in E, E in E, and Y in E. The first branch is what the alkane. The hydrocarbons that contains only single covalent bonds are known to be what? Alkanes. Okay, single covalent bonds like this. Alkanes, look at A in E concept, single bond concept. Homologous series is one in which adjacent members differ by a constant unit. A general molecule formula can be used for this thing. That is what CnH2n, CnH2n plus 2. Look at for the ethane we described here, like where n is what? The number of electrons here, or number of carbon atoms, sorry. Look at the hydrogen atoms as well, like H2 and 2n after that. So the ethane came and the propane came respectively by putting all of the number of carbons or the number of atoms here in this formula. Okay. Then the cycloalkanes came like the branched one, the cycling one. Cycloalkanes are alkanes in which the carbons atoms are arranged in a ring or cyclic structure. So in spherical representation, it is understood that there is a carbon atoms at each corner and enough hydrogen atoms to complete the 4 bonds of each hydrogen atoms there. Cycloalkanes, look at the general formula for cycloalkanes are what? CnH2n only. There is no plus 2 at all. Okay, for the non-cyclic one, like the typical alkanes, we are using what? CnH2n plus 2. Got the idea? Systematic names of alkanes, then we studied like the unbranched chains alkanes nomenclature. To name the unbranched alkanes, use the prefix that corresponds to the number of carbon atoms in the chain of the hydrocarbons, and add the suffix A in E, as I told you. Look at A in E, single bond, E in E, double bonds, triple bond, and Y in E, triple covalent bonds. These are all covalent bonds, remember. All the bonds are covalent in nature, as I told you. Ethane, ethene, and ethyne as an example. This is alkane, alkene, and alkyne. Systematic names of alkanes. Historically, again, it is continued. We have a great system we call them IUPAC system, which can give us the name to a pure organic compounds. Okay. Names of alkanes, look at methane, ethane, propane, butane, pentane, CH4, C2H6, C3H8, C4H10, C6H12. These are what the structure formulas for those things. Melting points, and these are the boiling points, remember. Systematic names of alkanes continued. Branch and alkanes nomenclature. Alkyl groups then came. The groups atoms that are formed when one hydrogen atom is removed. Let me arrange this thing for you guys. When one hydrogen atom been removed from any typical alkane like CH4 structure. Look at the structure, CH4. So if you remove this H from here, it will lead to what? Alkyl groups then. Got the idea? Now look at here, CH4 methane. Then look at straight chain alkyl groups. Alkyl, methane, then ethane, propane, butane, pentane, methyl. Now look at this methane, CH4 being converted into CH3. Why? One hydrogen been removed. Got the idea? So we call them what? Alkyl groups then. Then the systematic name of alkanes still continued. The 3 carbons branched and alkanes nomenclatures suffix A in E again. Got the idea? Branch and alkanes nomenclature arrange the names in alphabetical order in front of the names of the parent hydrocarbons: ethyl, methyl, octane, ethyl, methyl, octane, ethyl like 2, methyl like first, and octane like 8. Ethyl trimethyl. Ethyl will be there, like ethane will be converted into ethyl, and the trimethyl, like there will be 3 known groups of methyl being attached to the octane. Properties and uses of alkanes. Typical uses: carbon atoms. Let me make it arrange. Yeah. Properties and uses of alkane. The carbon hydrogen bonds of alkanes are non-polar. There is no polarity at all, of course. They are just binding to each other, and covalents are in nature. So alkanes molecules are non-polars. The only force of attraction between non-polar molecules are weak Landau dispersion forces. Landau dispersion forces are stronger when the molecules are larger. So physical states of alkanes are a function of their molecular size. Okay. Then comes to the physical states. Alkanes that have a lowest mass, those with 1 to 4 carbon atoms are gases. Natural gas is a fossil fuel composed primarily of alkanes containing 1 or 4 carbon atoms. Larger alkanes such as gasoline and kerosenes are liquids. Got the idea? I make it broad, you can say. Yeah, now it is okay. So make it like this. It's okay. Natural gases, fossil fuel. Larger alkanes such as gasoline, kerosene are liquids. Alkanes that have a very high molecular mass such as paraffin, wax are solids. Got the idea? Now the properties of alkanes as well. The hydrocarbons molecules in petroleum contains 1 to 4 like carbon atoms. Boiling points. Look at the fractional distillation process for the oil, crude oil preparations, and this or that. They've been separated. It is a process of components of a mixture that are separated on the basis of boiling point by condensation. Got the idea? By condensation. Let me make it work for you guys as well. Yeah, it's okay. By condensation. And vapor in a fractionating column. Got the idea? Now again, the functional group came here. Functional groups, classes of organic compounds. Look here. Functional groups are what? A functional group is an atom or group of atom that is responsible for the specific properties of an organic compound. Okay, let me make it some bold for you guys so it will be better you can understand to you guys. Now look at a given functional group undergoes the same types of chemical reactions in every molecules in which it is found. Compounds that contains the same functional groups can be classed together. Classes of organic compound. Again, let me make it you can say bold for you guys. Yeah, a functional group gives you organic compound properties that are very different from those of corresponding hydrocarbons. The compounds in the table on the next slide all we have 4 carbon atoms. All those things that are just coming up. Okay, classes of, look at butane, 1 butanol, butanoic acids, 2 butanone, diethyl ether. Structure formula for the butane is this one, melting point is this, boiling point is this, and density is this for this thing. Common organic functional groups: alcohol, ether, aldehydes, OH. Look at CC, in the middle we have O, CH double bond O, we call them AL, aldehydes, ethers, all. This is the example. Isopropyl, what, like same, propyl, 3 carbon, 1 2 3 1 2 3 1 2 3, isopropanol. These are the properties. Some properties similar to water, able to form hydrogen bonds, useful precursors for many compounds like this. Understand? So these are what we studied. You know why I'm just floating away? The thing is, what you need you people need to cover and to study all these slides again and again. Understand? And I will send some snaps to the last review pages to Asim. Understand? I will send it to them and he will send it to the group. Or okay, for you guys, the last summary page. I was not able like to copy from the book. Okay, that was in PDF, and so I don't have any format for that thing to copy to print the screen. So that's why to make it more clarify and visible for you guys, I will send it to Asim. Okay. Classes of organic compounds. Alkyl halides. Alkyl halides are organic compounds in which one or more halogen atoms, fluorine, chlorine, bromine, and iodine, are substituted for one or more hydrogen atoms in a hydrocarbon. Alkyl halide Teflon. The non-stick coating of this pan is made up of Teflon and alkyl halide. Classes of organic compounds. Ethers. We have ethers are organic compounds. Ethers are organic compounds in which two hydrocarbon groups are bonded to the same atom of oxygen. General formula for the ethers are what? ROR, where R represents the hydrocarbon groups, either the same one is R or a different one. Ethers are not very reactive compounds and are relatively non-polars. Get the idea? Ethers are commonly used as solvent like water. Classes of organic compounds. Aldehyde and ketones. Aldehydes and ketones are often responsible for certain odors and flavors. Better, Mr. Ahmad Hamid can explain this thing. We have odors. That guy can produce and can make, you can say, different kind of odors. Understand? Like the fragrance, all. Oh my God. Now look at, we have almond, pure vanilla extract. These are the raspberry. All we have cinnamon here as well. Understand? So these are the vanillin. Okay, benzaldehyde, raspberry ketone, cinnamaldehyde, and this is iron as well. Got the idea? Amine. Wow, this mandik. Look at this is what we call them in Urdu. We call them mandik, and in English we call them frog. This is just the most dangerous frog ever, you can say. Okay, bitter toxin A. The poisonous dart frog produces toxic amines, one of which is beta-cortoxinin A, that kills nerve cells directly. Your mukh will be kharban. The nitrogen atoms of amine is shown in red. Classes of organic compounds. Carboxylic acids. Example of carboxylic acids are acetic acid, citric acid, benzoic, propanoic, sorgobic acids. These are found where? Weak acid is present in vinegar. This is present in the lemon. In the upcoming slides you will study it. The carboxylic acids are much weaker than many inorganic acids such as hydrochloric, sulfuric, and nitric acids. Esters present where? In bananas. Esters in bananas can be synthesized and used as flavoring. Esters, these are the structures as well for the esters. Butanoate, methyl salicylate, or geranyl formate, okay, methyl anthralenate, linyl acetate, wintergreen oil, pineapple, it is present, okay, rose, this one, geraniol, then grape juice and jasmine, this one is for the smell as well, and lavender as well, we are using as a room spray here, air fresheners. Classes of organic compounds. We have ethers that we studied before as well. Organic compound in which two carbon and hydrogen are bonded, groups are bonded to the same atoms of oxygen. General formula for an ether R represents hydrocarbon group, either the same or R is the different one. Ethers are not very reactive compounds, relatively non-polar. Ethers are commonly used as solvent. Remember, I will send some snaps regarding the review solution to Asim on his phone, and he will distribute it to you guys, okay, in the group. Thank you so much, and fi aman Allah.